Welcome, or welcome back to those who've been with us earlier today, and welcome to those of you who are just joining us now for the third and last panel of our Aviation Summit, Enabling Green Operations Through Datalink Standards. This session, after the opening panel and the two previous sessions, will now look at another dimension, focusing a bit more on the operational side and how data link technology can also have significant positive impact on the environment. Before going into the session itself, I'd like to remind you to use the Q&A tab for any questions you have for our panelists. Recordings of the session will be available in the events lobby for a month now until November 24th. Speaker information can be found on the speakers tab. And if our speakers are giving us permission to share the slides, they will be available in the events lobby later today. And with that, I'd like to turn it over to our esteemed panel here. Thanks to all of you for joining us today on stage. And the session is moderated by Wes Gooch of American Airlines. He's a technical pilot, airspace and aircraft modernization, and member of relevant groups, both in EUROCAE, RTCA, as well as at FAA and ICAO level. So over to you, Wes.
Thank you, Anna, for that very gracious introduction. What I'd like to do is introduce the team today that's going to be presenting. First of all, I'd like to introduce Anna Barouaz. If she would bring herself on screen. Anna is a system level engineer and data link expert with Eurocontrol Maastricht Upper Area Control Center, and is an ATS B2 and ADSC plus CPDLC expert. She'll be joining us and talking first in the presentations. Second today will be Kathy Torrance. Kathy is from the FAA. She is currently the program manager for Datacom for the FAA. She's worked with several other automation systems for the FAA, ERAM, ATOP, TBFM, TFMS. She has a world of experience with the FAA in doing and managing these programs, and we look forward to her comments. Our third presenter today is a friend of mine, Rocky Stone, who is currently now a new employee of the NTSB, but in his previous life, he was with United Airlines. He was the chief technical pilot for surveillance at United. He also was the co-chair of SC-186 at RTCA, which is the ADSB technology, and SC-206, which is aircraft or aeronautical information service data link, I'm sorry. And then lastly with us today will be Kieran O'Carroll. And he is an avionics expert and specialist with IATA. He's currently based in Miami, and he will be joining us for the last presentation of the day in our Enabling Green Operations Through Datalink Standards. So with that, I know that at American, we do a lot of business in Europe and flying to destinations there. And Anna, I know that Eurocontrol has been heavily involved in data link for decades. And as such, I'm sure that you have a lot of interesting information to share with us about current and future possible operations with data link standards. So I'll turn it over to you, Anna. Thank you.
So Maastricht Upper Area Center, Control Center, it's covering or managing the air traffic in 4 countries, Belgium, Luxembourg, Netherlands, and northwest part of Germany, from flight level 245 to flight level 660, and is one of the busiest and most complex airspaces in Europe. Probably that's one of the reasons why MUAC has a long history with Datalink. We were back in 2001 when we first implemented CPDLC version 1 operationally, and then MUAC was participated in several trials and validation for ATS-V2. And in July 2019, CPDLC version 2 became operational, and ADSC pre-operational. Only a group of controllers were having this functionality available for validation. And because the assessment was very positive, in May 2022, at the full ops room, more than 600 controllers were having this functionality available on the screen. And we plan to continuously evolving what we have right now at the moment. Here are in the screen some of the facts on Datalink of daily average of MUAC. You can see that we manage more than 5,000 flights per day. 83% of this traffic is Datalink equipped. So we have a lot of experience of that. And even if at the moment it's mandatory to log on with our center, still today, more than 50 times per hour, our ATCOs are requesting the pilots to log on. And this is a huge amount of time. Regarding ATSB2, we can say that we have at the moment only 152 aircraft equipped with this new technology. All of them are Airbus, but we expect that in the near future for 2028, there will be other aircraft manufacturers implementing this fancy technology. And usually daily we have like 92 connections of this aircraft. What do we present to the controllers on the screen regarding ADSC? So controllers can see the airborne trajectory, so the standard projected profile, the EPP, which can contain more than 128 waypoints. And they also can see that graphically, it's this green line. Sorry, there is someone talking.
Okay, I'll turn it back.
Sorry. Sorry, yeah, I was saying that the EPP trajectory is there on the screen in pink. And they also, our system is all the time checking for discrepancies between the air and the ground trajectory. And if there are problems or discrepancies, then there is a question mark presented to the controller so that they can solve it. They also can see the top of climb and top of descent as presented receiving from the aircraft. And they also have functionality to request an interval for the earliest and latest time the aircraft can make it over a specific point requested by the controller. With all these functionalities, we see already many benefits for the controllers. The first one is the big safety enhancement because they have much more information of what the aircraft intentions are, the trajectory, the cruise level. They can also, for example, see that we have a workload reduction and higher efficiency because there is this push to load functionality on the aircraft side. And that makes easier for pilots, but also for controllers to uplink more complicated clearances. And also they can be checked that they are properly implemented thanks to the EPP being downlink. Apart from that, we see that as the first step for automation on the system, and controllers can provide a better service because they can try to give more shortcuts when they see the EPP trajectory, even going further to our airspace. And also they can try to accommodate for less steep climbs and less steep descents. For the pilots, this also brings workload reduction and higher efficiency. The lateral clearances that there are loadable, it's a big advantage. And then, of course, because controllers can see many information on the screen, they don't need to ask pilots via radio for information. So at the end, this is saving also time for the air crews. And we see that with this CPDLC version 2 and the push to load functionality, we get 25% quicker response compared with CPDLC version 1 on complaint clearances. Apart from that, there is also a big safety increase on the airborne side because the post to load makes things easier and there are then, of course, less errors from the flight crews. And also, yeah, we have seen that, for example, there are sometimes a lot of misinterpretation on the pilot side with certain clearances, for example, with UM79, which could have been avoided if ATSB2 would have been used. For the airlines, mainly we see the benefits of having more environmentally friendly flights because they will get more optimized climbs and descent profiles thanks to the display of the top of climb and top of descent. Controllers will try to accommodate to those if the traffic allows, of course. And we have here some examples. You can see there in the picture that with an ATSB2 flight, usually and with the EPP and CPDLC, when ready clearance, controllers can let the aircraft fly and not give a descent of 1,500 feet per minute, which is usually what happens when the aircraft is ATSB1. And we have there the total number of savings of a period of time, and only with the 152 aircraft that we have at the moment equipped, flying around our airspace. So more than 20,000 nautical miles maintained in cruise level, more than 16 tons of fuel saved, and 51 tons of CO2 emissions saved, which is not bad. And also the airlines can get, or the flights can get, more optimized routes and less mile flown, thanks to that we can see what are the intentions of the trajectory of the aircraft beyond our airspace, and try to accommodate some coordinates from some kind with the downstream centers. We can also uplink lat-long coordinates, which it's more advantage functionality only for B2 compared with B1, that instead of giving longer reroutings. And for example, in the example that you can see in the bottom right of the screen, it's only a shortcut of 5 nautical miles at level flight 380, but it can mean for an A320 family saving of 25 kilograms and 78 kilograms of CO2. And for a 320, 55 kilograms of fuel savings and 175 kilograms of CO2 savings. So as a summary, for controllers, it's a big safety enhancement. They have more information on the screen. The system is automatically checking for discrepancies. There is a workload reduction and also an improving on efficiency because they are using also less the radio frequency for checking. They can provide a better traffic management and better config detection because we are including parameters coming from the aircraft on our system to have a more accurate calculation. For pilots, it's also safety enhancement thanks to the push to load button, workload reduction, and also improving efficiency. For the network, we expect that because of the ADSC common service introduction in Europe, that will provide the ADSC information from the takeoff of the flight till the landing, we will be able to have a better prediction of sector loads and runway occupancy times, also leading to more effective traffic management in collaboration with all partners, and that will be enabling capacity increase. For the airlines, as I was saying, the main benefits for them is that they will be saving fuel, saving CO2 emissions, and also time saving thanks to the optimization of the profiles, less steep climbs and steep descent, and also route shortcuts thanks to the EPP and the CPDLC version 2. And in general, that will make the flights being more environmentally friendly, more green. And for the future, we also expect that we will have improvements in the meteo models used by the ground thanks to the meteo information received from the aircraft. Also enhancements in the TP computation for the standard AMAN predictions, also absorbing time in cruise level instead of having the flights being on hold. And again, enabling automation, and this is the main pillar for trajectory-based operations. Thank you.
Thank you, Anna. That was very informative. I can tell you from Americans' perspective, the ability to get the cruise altitude quickly and be able to delay our top descent to the last minute obviously does save us fuel and things of that nature, and that's very beneficial for us as a major airline. I'd like to turn now to Kathy Torrance from the FAA, who's going to introduce our work here in the United States with Datacom. Kathy?
Thanks, Wes. Yeah, Anna, that was a great presentation, and you're going to see some similar themes here throughout mine. So to date in the U.S., the domestic Datacom program, we have capabilities at 65 towers and 12 air route traffic control centers throughout the domestic US. And we're going to talk about some of the statistics for time, fuel, and CO2 emissions that were prevented. So we'll talk about that a little bit and where we are with the program. So overall benefits here, again, we're providing those services between pilots and air traffic controllers, supplementing the voice communications capability. So there's no intent for Datacom to ever, or Datalink to ever replace voice. This is a supplementary system. By introducing and providing that data link between ground automation systems as well as the flight deck. And the messages that we share include clearance clearances, instructions, traffic flow management, and also requests from the crew. We actually have today with fans the push to load capability already. So we're able to take advantage of those benefits that Anna mentioned are coming in the next segment of CPDLC in Europe. So again, controllers are able to deliver instructions with a push of a button, right, without having to be on frequency. And one of the real benefits that we see, especially with the push to load, is those transmission of complex instructions that can be directly loaded in through the push to load. And that really does save time. We'll talk a little bit about that, or what we're seeing on en route. And also from the US perspective, the implementation of Datacom really provides the foundation for upcoming other next gen initiatives like TBO and some others as well. And again, for benefits, we're very much what Anna said as well, right? We're reducing that communication time between controllers and pilots, improving rerouting around weather and congestion. She had a great graphic there that showed that our controllers are able to, instead of having to go only with published points, they can basically trackball pick around weather or some other area that pilots need to avoid and get them as close as possible, which saves fuel. As well as we're able to increase that flexibility and accommodation of requests from users, which can save CO2 emissions. And then again, as I mentioned, we are able to provide that standard for other next-gen initiatives and TBO. So this is where we are from deployment from a US perspective. The triangles are the 65 towers and their location. We have multiple colors going on here, so I'll explain a little bit about what that is. So for the centers that are colored in, that are green and purple, they are providing CPDLC 24/7 currently. For the ones that are purple, they have decided to accept the capability and have achieved an FAA milestone known as IOC, or Initial Operating Capability. You'll see Jacksonville there is shaded kind of a peach color. They just started bringing up Datacom, and the good news is, as of last night, Fort Worth did the same. So we have a change in our map here. Fort Worth just came up, but in a limited capacity. So when we first bring up a center, they come up in the evenings when traffic is lighter, and we'll turn it on for a few hours to help identify any issues, make sure their adaptation is correct, and then they'll turn it back off, make any corrections in their local adaptation, turn it back on for a few hours again overnight, increasing the amount of time that it's on with each run. That lasts about a month until they're up 24/7. And the great news for us from the US is that we're now able to provide CPDLC services from coast to coast. We had our first coast to coast flight back in March of 2023, which is a really big accomplishment for the program. To date, we have 20 Part 1 US air carriers, 92 non-US air carriers, over 19 business aviation operators. We're again at 65 airports. We have over 70 aircraft types, and the bottom right there, we have over 10,000 equipped aircraft. Our original goal for Datacom was to have 5,000 equipped aircraft by this point in our deployment, and you can see we've more than doubled that. So we're really excited about the participation from our airline partners that are using this service. And then looking at some of the savings. So just in August of 2023 alone, DCL at the towers have saved over 100,000 minutes of radio time, as well as airspace user time, 81,000 minutes there. We've cleared in just that 1 month alone over 272,000 flights and prevented over 3,000 readback errors. And since 2016, which is when we first deployed DCL, you can see our metrics down below, over 2 billion passengers saved, and we've prevented over 45 million kilograms of CO2 emissions by allowing for faster communication between the pilot and the controller. They get out of the gate sooner, less taxi time, which then equates to savings in fuel and CO2 emissions as well. And if we look at that over time, we did actually take a look at one tower in particular. This is for Orlando. And you can see on the right the cumulative CO2 savings that we've seen just over the last year. I mean, you can see on the left the time savings and route revisions. You know, it really depends on the time of year, how much savings there is. But again, looking at overall, the numbers continue to go up. We continue to have new users from a tower perspective as well as from en route. From an en route perspective, so we've had over 34 million, almost 35 million transactions to date. We started deploying this in March of 2019. Unfortunately, we did run into the COVID pandemic, as I'm sure many other programs did. So we had to pause while until it was safe for our controllers to start training again. And once they did start training again, we've really picked up the pace to try to fill in this map as best we can. But to date, we've had over 5 million sessions, and again, 26 commercial aircraft types, 36 operators, and for en route, we have almost 5,000 equipped aircraft. And you can see to the right, the readback errors that we've saved. I saw on Anna's chart, and the same for the US. One of our big advantages and benefits is efficiency and safety. And in efficiency, you can see almost 3 million minutes of comm time saved just in the time that we've been running with en route since 2019. So my last example I want to just talk about, and this Anna actually had a much better graphic. I wish I would have had something quite as good, but this is just an example of a time when en route CPDLC was able to help one of our centers. So in this particular example, ZDC was very busy. There was a lot of weather in the area. They had 3 AFPs. There were temporary flight restrictions, miles and trail restrictions, and we also had, in this particular example, 3 southbound flights who all got a similar reroute in ZDC. For the aircraft that were CPDLC equipped, that alone saved 129 seconds of communication time. So kind of going back to the push to load, right? The amount of time that it would have taken on the radio to read that clearance and then for the pilot to physically enter that clearance, that ends up to provide pretty significant savings just on one flight. And then when we look at it across the US, it's great numbers, great savings. But for this particular example, they were able in their reroute to save 39 nautical miles, 6 minutes. And again, you can see the CO2 emissions and the fuel that was saved as well. So yeah, we're definitely excited about rolling out Datacom. These benefits that we're seeing are tremendous. Again, our numbers are ahead of where we thought they would be. So we're really, really happy to be a part of this program. So back to you, Wes.
Okay, thank you, Kathy. And as a user of Datacom in the US, we can say that our pilots have really enjoyed using it. They like the ability to be able to make those frequency changes and get these reroutes and be able to do that without getting into the hearback readback issue that we traditionally have fought over the last 4 or 5 decades. So it's been a win-win for us. I'd like to introduce Rocky now, who's going to talk about Datalink standards for improving safety and efficiency. Rocky, take it away.
Hey, thank you, Wes. Welcome, everybody. First, I do need to qualify. These are my own views. I'm not representing United Airlines, my former employer, or the NTSB, my current employer. But after many years of working with RTCA, I think these are some interesting ideas that a little bit of a gear shift from what we just heard with CPDLC, which is actually a tremendous capability. But I'm going to talk about things that cause even just minor delays or minor capacity reductions, and things like playbook routings that cause blocked, flight times to exceed block times, and it ends up being disrupting the airline's schedule integrity, especially when an airline hub is scheduled at very close to its capacity, which many of them are nowadays. And so my pitch is that the service providers need to be able to mitigate these capacity reductions and improve reroute efficiency so that we can gain back some of what we're losing as far as schedule integrity. I'm going to make a pitch for flight deck interval management, which I call it the last mile of trajectory-based operations. Steve Bradford talked about trajectory-based operations earlier, and really And on my next slide, you'll get to see why I think FIM is such an important last mile to TBO. However, I do want to talk about FIM is really, it's a cultural change in how ATC operates. And American Airlines is actually doing a trial, and Tim Murphy earlier talked about trials, and this is a really good one where they're using kind of a, it's called CDTI assisted separation. And, it's kind of a first step. It's one of the first ADS-B applications that I think an airline can really see there's potentially significant benefits from, and it's a stepping stone to get us to FIM. And Wes, I don't know if you want to make a comment on what you guys are seeing with the airs.
Well, actually, Tim, we're seeing a lot of success with this. My manager at American has led the charge at our company in working with ACSS on the development of a product that we have installed, and roughly almost over half to 2/3 of our Airbus 321 fleet. As you said, we've currently having an ongoing agreement with Albuquerque Center to run interval management with designating aircraft ahead of us, and then achieve a time by a fix in the procedures that will lead into the Phoenix hub that we have. We're seeing a lot of gain with that, and controllers, as you said, are starting to make that paradigm shift and get their heads around how this can help them, and they're actually finding better ways to use it, which is what we thought would happen. As far as the Dallas program with CAVs, we also see that pilots are starting to use this technology, and they're figuring out ways to use it, as are the controllers in Dallas. Again, it was another paradigm shift for people to understand that we could take this technology and actually create somewhat of a visual approach scenario, even though the weather may not be perfectly visual, it might not be 1,000,000 miles and 10,000 overcast. We have the ability to designate aircraft in front of us, and therefore we feel comfortable in following someone when maybe the airport may not be in sight, but the traffic we're following now is clearly available to us on the CDTI inside the cockpit. Back to you, Rocky.
Okay, thank you, Wes. So I want to talk a little bit about throughput, and Wes talked about the FIM that American is doing, which is actually en route FIM, which is actually an important. It's a step into, but I'm going to jump into arrival throughput, which is really FIM down to the runway. And I've got an example here, and I think this is important just to understand, why I'm trying to promote FIM as much as I am. Today, with pretty much what we see with the tools that controllers have available, the inter-arrival time standard deviation is around 18 seconds between arrivals at the runway, and that leads to the efficiency that we see down in of 38 arrivals per hour theoretically. And then these next two examples are what could we see with the best possible ground-based decision support tools, and we think that you can get that standard deviation for the inter-arrival time down to 12 seconds. That would be a pretty significant throughput increase, up to 44 aircraft per hour. But if you can meet the inter-arrival time standard deviation that FIM has in the standard in DO 361 of 5 seconds, you could theoretically get up to 55 arrivals to a single runway per hour. And so, and the only reason that I'm really wanting to harp on this is I think it's really important to understand the effect that precision spacing on final has, and you really need a much tighter control loop than is possible with the ground-based decision support tools and ATC today. And that's why I'm trying to be a proponent of FIM in the terminal area. Next, I'm going to shift gears and talk about another thing that can add a lot of time to a flight, and that's playbook routing. And this is actually a picture of the West Coast of New York City playbook routing, and you can see from lots of different origin places, and you can kind of visually see that it's quite a bit out of the way. It would not be unusual from Southern California to have this kind of a playbook routing add an hour of flight time to the the good news is it doesn't happen all that often, but during convective season it's a rare but normal event. So my pitch with this is the next slide. If we'll go to SC206 is working on an airborne reroute information service, and it's basically, it gives you it's trying to specify the minimum information content that a pilot needs to be able to make legitimate and useful inputs into the rerouting situation. And the only point that I really want to make on this is, SC206 is working on it, and I hope if are those interested that they'll join the group. But it really is going to take the CDM community within the FAA, at least, to embrace the concept to allow for its use. So without that, it's really not going to go very far. So hopefully, that will happen. And then the last thing I want to talk about is a little bit about leadership, and this kind of touches on what Tim Murphy and Steve Bradford were talking about earlier, as far as trying to what does it take to implement new technology. And I've offered two different things today that I think would go a very long way to improving safety and efficiency and mitigating the schedule integrity issues that airlines have, when benign ceilings and visibility cause a 10 or 15% capacity drop at an airport. CAS and FIM are both things that will really mitigate that. And then the ARI offers the possibility of improving the efficiency or allowing ATCB to be a little bit more nimble with rerouting around convective weather as the situation is changing. But my last pitch is and this kind of goes back to the plan that was laid out this morning, which is why I'm pretty excited about what's been going on today, that there needs to be a clear roadmap that goes all the way to embracing these capabilities. And that would really allow operators to make intelligent decisions. The roadmap needs to be how do we interoperate with today's system? How do we mix FIM in with non-FIM, which that's going to be huge. And how do we get from what American Airlines is doing with their AIRS program to the ultimate end, getting the most efficiency out of the system with CAS and FIM. And that's my pitch, is that we really need the air navigation service providers to collaborate with the airlines, but lead the way and really tell us when we need to implement things so that we can gain some of these efficiencies back. And that's it for me. Thanks, Wes.
All right, Rocky, thank you. Great presentation, and we certainly concur with your opinion. We'll talk about that more later, maybe in the Q&A. This time I want to turn it over to Kieran O'Carroll at IATA to talk to us about the future as he sees it from IATA's perspective. Kieran?
Thank you very much, Wes. If I may, I would like to take 3 points from the presentations and panels that were made earlier this morning. Tim Murphy from Boeing, he talked about the fact that in the 2035 timeframe, the infrastructure and the aeronautical spectrum we currently have will not support the amount of data and the types of data we will be transmitting air, ground, ground, air. So clearly we need to do something about that in terms of standards and green operations. Cloud from Airbus, he talked about the use of potential commercial, therefore telecommunications infrastructure, to offload the aircraft services and data that don't particularly require a safety of life standard. So there are opportunities, of course, in the 2035 timeframe to do something like that. And basically, Steve Bradford spoke about something that's near and dear to my heart, which is offloading the triple stacking of aircraft to ground infrastructure. There's no reason we need to be triple stacking aircraft in 2035 so that they can operate transatlantic, for example, or in Asia Pacific. So the use of ground cloud infrastructure mainframes to basically do all the necessary translations will give us a much better opportunity to lighten the aircraft, green the aircraft, and save fuel. So basically, I would start my presentation by saying it's never too early to involve the airlines. We really appreciate the work that the EASA, FAA, Airbus, and Boeing have done on the white paper. but we would suggest that perhaps now that that document is in existence, it's not too early to start communicating with the airlines. I know that, for example, airlines are involved in SAR and of course in NextGen, but I think a wider community is necessary here since airplanes operate globally, as we keep on reminding ourselves. So as I see it, a future Datalink standard 2035 for green operations, the airlines will need to be in the decision from the outset. We will need positive cost-benefit analyses. We will need global harmonization. I heard this morning that there were 73 standards in existence, I believe, as computed by EASA and EUROCAE. 73 standards, we obviously have a problem there. We need some spectrum efficiencies because, let's face it, some of our systems, our legacy systems, were designed back in the 40s or earlier, and frankly, we are getting tremendous commercial pressure from the telecommunications industry. All I need to say is 5G and $1 billion for a sliver of spectrum, and you can imagine the type of pressure that is coming towards the aviation industry. There is a possibility of multi-industry development of standards. So one of the things I have in mind is the fact that we don't necessarily have to be inward looking. We can be looking at other industries who have spent money and who have the spectrum that Tim Murphy was talking about this morning. And basically, perhaps there's an opportunity there for the aviation industry. And of course, as always, there may be some COTS opportunities, commercial off-the-shelf opportunities for us in the avionic business. Let me see if I can advance the slides. Yes. So this presentation, this slide was used quite a lot. And the only comment I would say is that airlines simply can't afford to pay for a multitude of standards. We heard this morning about the fact that FANS is basically the standard in the United States. We're talking in Europe about ATS and ATS-B2, ATS-IPS at ICAO. The airlines simply can't afford to pay for all of this and to stack the aircraft with each of these systems. So when I look at this chart, I see an opportunity. We basically need to create technologies in the 2035 timeframe. I'm reminded that John F. Kennedy gave NASA, what was it, 8 years to land a man on the moon. So, you know, I appreciate there was a lot of money involved in that. However, you know, in 2035, surely we can do better than this. Now, IATA is moving forward beyond RFI, beyond radio frequency interference. Nobody, I guess, on this call needs reminding that the telecommunications industry is moving at a tremendous speed. Your phones change every 18 months or less. The telecommunications industry has spent literally billions of dollars on spectrum, and they are moving into our domain. They are moving into aviation, whether we like it or not. This chart on the left-hand side shows you what the telecommunications companies are now offering in terms of aviation services. Certainly, a lot of it relates to UAS, UTM, but basically don't think for a moment that this won't move into more conventional avionics. So IATA is currently working on the new edition of our user requirements for air traffic services. You see it on the right. We hope to publish it in December. And in that document, we will recognize the fact that there are opportunities in the 2035 timeframe to collaborate with the telecommunications industry in terms of the spectrum usage, in terms of the technology, and as Tim Murphy talked about this morning and others, simplifying the aircraft avionic infrastructure to the point where all the grunt work, all the computing grunt work is on the ground, and we can basically simplify the aircraft in terms of avionics and weight. Now, let nobody be under illusions. Changing standards is a cost to the airlines. And clearly, 5G was a classic example of how things can go badly wrong. IATA estimates that 5G has cost the airline industry $637 million. And that was just simply for the rad-alt upgrades. So we can't afford to do this with every other system on board, every other avionics system. Clearly, we have to take proactive action to ensure that in the longer term, and I appreciate this will not happen tomorrow, but by 2035, it certainly should be possible. So we need to take action to and appreciate that the airlines are paying for all of this in terms of standards. Now, I recently found a survey conducted by RTCA Eurocay, which I found very interesting. It was the survey on radio frequency performance standards for RF systems. And I found 31 instances of the phrase no corresponding maps document. So in effect, our legacy avionics systems are at the mercy of spectrum trawlers who believe that RF engineering standards, modern standards, apply to all spectrum users. For those of you who were involved in the 5G debate with the telecommunications industry, and I was one of them, it was clear that the telecommunications industry could not believe that we were still using double sideband AM on the VHF band. It is just simply beyond comprehension to them that we are that far behind in terms of RF technology. Now, we all understand in the aviation business why. This is a cost to the airlines, and certainly the standards for more modern software-defined radios and everything else comes at a tremendous cost when you're equipping the global fleet. But this is what the telecommunications industry is looking at. They're looking at the fact that we are using spectrum in some cases in an inefficient manner. And so basically they use this lack of modern RF engineering against us in these cases, especially at the FCC. Now, when I was asked to do this presentation, I said to myself, Datalink standards for green operations and the conventional standards that we're all used to and we've spoken about quite a lot, maybe not the answer in the 2035 timeframe. There are other standards out there. The telecommunications industry standards, for example, that are being used to create a tremendously broadband data links for phones and other services. And possibly we should have the foresight in our industry to look towards those standards and look towards those standards organizations that might be able to generate harmony between the two industries and benefits for the two industries, as I say, especially in the long term. So certainly something I would encourage in the standards arena. Here is an example. 6G is currently on the drawing board. And there is an opportunity right now for the aviation industry to have an input to the 6G standard. What can they do for us in the aviation business that will also give them, that is the telecommunications industry, an opportunity? So it is certainly future. It is certainly going to be global. It is harmonized to some degree, better than the aviation industry. It is a standard in development. It is RF efficient and it is green. So essentially what I'm encouraging is our industry and those specialists in the standard setting organizations to engage more fully with these telecommunications standards organizations on 6G. 5G is a done deal. We can't do anything about that. But 6G is still a decade away, and now is the time to engage and see what we can do in terms of lightening the aircraft in terms of weight and creating the ground infrastructure to do the necessary grunt work on the ground. Okay, so to finish up, my thought process is that by 2035, the art of the possible is that aviation and telecommunications can have a harmonious relationship where there will be standards setting between the two organizations, between the two industries, I should say. And it is possible in my simple mind that we may have a 6G aircraft connectivity standard by 2035, which will satisfy the need for green operations in that time frame. Thank you very much for your time and attention today. Back to you, Wes.
Thank you, Kieran. Very interesting comments from IATA. I'd like to ask all our panelists to turn their cameras back on and we'll join back in the kind of a roundtable discussion. I don't currently see any Q&A, but what I did want to is comment on a couple of things you said, Kieran, and it's kind of been the theme. You know, the airline industry, or let's just say the air transportation industry in this country and around the world, is looking to provide connectivity for people to get from point A to point B as easily as possible with the schedules that they want, their demand, because, you know, we're a customer-based type of service provider. But at the same time, we provide a level of safety that has to be recognized and acknowledged around the world, because what we do involves safety of life. We're taking people and putting them in an airplane, and we're taken off and moving to other parts of the world. And so there has been historically safety implications that we have all strived to make sure that we give the most possible safe travel to the traveling public. So to your point, Kieran, I think about the collaboration. To me, collaboration is important because I've been involved in the 5G discussion, and at times it's been complicated. Let's just put it that way. But the bottom line is there has to be a recognition on both sides of what each group brings to their own table and what they're dealing with, but a recognition on the other side of what others, especially in our organization, have to deal with as far as safety implications. And I think somewhere there's a disconnect. We have to make sure that collaboration is solid, that the information transfer back and forth is complete so that we understand their systems as well as they're going to understand ours, and they have with the 5G discussion. But to anybody on the panel, I kind of put that out there. How important will that be going forward for the next 10 or 15 years?
Well, perhaps if I can just jump in first,
Sure.
I completely agree with you. The situation really is that we must do the safety of life input to 6G now, before the telecommunications industry develops that standard. They're only at the starting gate at the moment. And certainly if we are to benefit from that, and I bring up the point of the spectrum, our spectrum usage is going to be absolutely critical in that time frame, in that 10-year time frame. We are obviously under tremendous pressure. I think most people online probably are familiar with the fact that the NTIA in the United States is seeking to repurpose 1,500 megahertz of spectrum at least. That's not the end game. So essentially, we are going to be under tremendous pressure on the spectrum side of the business for a long time to come. And it may not be a cheap exercise. We've seen how much 5G cost us, and that wasn't actually changing spectrum or changing frequencies of the RAVALs, just simply to fix the legacy technology. So I think you're absolutely right, Wes. We need to be looking at what are the safety of life implications for some of these other systems, for example, mentioned by Airbus this morning, offloading AOC type traffic, offloading engine data, offloading passenger traffic, back of cockpit type traffic. That situation is going to demand that we pay a lot of attention to what other operations and standards are available to us. Well, so I won't take up too much more time, but I completely agree. We need to be doing this stuff now. Okay.
Absolutely agree with you. I know that my esteemed colleague, former United pilot, Rocky, agrees with me. Airlines already have a steep financial hill to climb because we're in the process of repurposing, or I should say, re-equipping our fleets to be more efficient, which is the right thing to do, but it has a huge cost with it. And to your point and others, having multiple pieces of equipment that we have to buy to maintain the ability to move around the world doesn't really make a lot of sense. It's much easier for us to have one piece of equipment that serves all purposes as far as like datacom or the other issues that we've talked about. And there are other things that are growing out as well. I mean, we have to consider the fact that now GPS disruption is coming. It's not really for this panel, but it's another thing that we'll have to consider with new standards for multi-mode receivers, things of that nature. And then to the point of the support group, the FAA, Kathy, the FAA has to continue to make these investments. And I know, your comments about how the FAA deals with those budgetary restrictions, because, money is what makes this all work. It's not all just about someone creating a device, right?
Yeah, for sure. Definitely, we have budgetary constraints, but also one of the challenges is, especially for us on Datacom, and we live this in this field every day with, struggling with some of the interference on our frequencies more than anything, but it's also a matter of getting everyone together in the room who owns each one of these components. We have a lot of on our program technical interchange meetings where we'll bring in folks from Spectrum as well as avionics manufacturers, OEMs, air traffic. We all come together and we try to work through some of these problems and come up with sometimes pretty unique solutions, right, that can fit within our budgetary restrictions. But it's definitely a challenge. It's something that we deal with on a regular basis, but we're trying to work through it as best we can, but really getting everyone involved in the conversation, and not just one program or one program manager, right, but everybody who has a piece of this technology.
I would agree, Kathy. It makes perfect sense. Collaboration at its truest sense has everybody at the table, not just certain aspects. And I know, Anna, for Eurocontrol, I'm sure the same question could be asked as far as future development. I mean, there's a cost to it. You guys have to come up with this stuff to make it work. I mean, any views on from your opinion?
Yeah, there is a cost. And also the problem, for example, in Europe is that we have many different centers. And if we have to standardize something and new technology, all centers need to move. And we are not all in the same position. So it makes things even more complicated. It's not only for the aircraft side, which they need to spend also a lot of money equipping aircraft with different standards and things, but it's also to have the commitment of all the different NSPs in Europe to make the change, and in the time frame that you need, of course.
I totally agree. And I'm going to kind of wrap up our Q&A here. We'll actually see two questions. I'm going to bring them up. The first one, and I'll just see which one of you want to pick it up. What will motivate MNOs to provide connectivity for aircraft and commit to aerospace, I guess, KPIs? Sounds like maybe an Anna question. I'm not sure. Does anybody understand that one? I'm not sure what MNO stands for, but
I'm not sure about MNO, but a KPI is a key performance indicator. So,
okay.
So I know that. So if I'm interpreting this question as how do we motivate, and I don't know what an MNO is either, but I'm going to assume it's our customers, our operators, our airlines to provide that connectivity. I really think
network operators.
Mobile network operators. Oh, yeah. I'm not sure I can answer that question, but I will say for the rest of us, it's providing those benefits, right? And we really end up in this chicken or the egg kind of conundrum, right? Where we want to make sure that we're building to these standards, but we also want to make sure that we have customers who are ready to use them as well. And that's another challenge that I think all of us on this panel have with our various technologies.
I would say, Wes, if I may, in response to that question very briefly, I would encourage the questioner to go to MITRE Ingenuity. MITRE Ingenuity is, of course, part of the MITRE organization. They are involved very heavily in the aviation side of telecommunications, and they are working, of course, on the standards for UTM, UAS, etc. And they basically have been engaging with us in IATA. We have been engaging with them and trying to encourage some of the KPI type development work that is being mentioned. So yes, this is going on in the background with MITRE Ingenuity.
Okay, great. This last question I'm going to give to Rocky. We haven't heard anything about weather optimized routing and its potential to green aviation operations, standards allowing continuous, frequent, very few seconds aircraft-based meteorological observations to be broadcast via ADS-B Datalink for air-to-air and air-to-ground reception have been published by RTCA and EUROCAE and cited by the FAA technical standards orders. Are you aware of the ADS-B weather, and what do you think of its potential for greening aviation operations, Rocky?
Yeah, so thank you for bringing this up, Steve. I didn't talk about it in my presentation because of my limited time, but yeah, absolutely. Version 3 of ADS-B includes the transmission of weather parameters, and there's, in fact, to make FIM kind of work most efficiently, you really need to know if the wind on the other side of the terminal area is different from the wind where you're at right now. And one of the ways to get that is through ADS-B weather. And also, the other thing about ADS-B weather is, with all the talk about CPDLC that Kathy and Anna have done, once ADS-B weather is implemented, there's potential for a lot less voice communications, as pilots aren't going to have to ask, hey, what's the wind up at 350, or what's the ride like down lower or up higher? I mean, those kind of things will be displayed directly on an ADS-B in display. So I think what you've brought up is actually a really good example of, the sooner that we implement this technology, the better. And the reason is, I know just the US airlines there have literally over 1,000 aircraft on order. And, how many of them are going to come with version 3 ADS-B as a standard? And, the sooner that that we get some indication that there is a cost benefit and it is available and it is going to be part of the FAA plan, then airlines can make really good decisions to make sure that their new aircraft orders have that, because retrofit is just going to be really expensive and take a long time.
You're absolutely right. So I'm going to end up with just making a couple of comments, and I'm going to bring Terry, our chief moderator, back online. But all these things have been a great discussion for the last 50 minutes or so. The one thing I'll pitch, because Americans doing the AIRS trial, is that, for us as an airline, even if we reduce flight time by, say, 20 or 30 seconds in the terminal area, we get airplanes on the ground quicker. That's improved throughput, and that's what airlines are here to do. We're in the business of moving people based on the schedules they want. We know that schedules are published, but, sometimes schedules get messed up because people are messy. They don't always show up on time, and we try to accommodate the late runners, things of that nature. So not only do we need a good, efficient system, but we do need to have flexibility in there so that we can try to recover those nuances that we experience day in, day out. But every second or two that we save, even on one flight, builds up over time, and that time is recoverable in additional flight time we can offer as a service to our customers across the U.S. or around the world, for that matter. So with that, guys, I'm going to ask Terry to come back, because we're within 4 or 5 minutes of closing shop, for any comments that he might have. If not, I want to thank all of you for spending time with us today and with our esteemed group as attendees for this Aviation Summit on Future Connectivity. It's always informative to me because I learn things all the time, and we will continue to learn, because this is an evolution. As we know, as we move forward for the next 10, 15, 20 years, all of us will be evolving our own individual systems, whether it's aircraft, ground-based systems, or whatnot. It will be, from a connectivity standpoint, a collaboration activity as well. All of us working together to make that happen. So with that being said, I'll thank all of you, and I'll look for our hosts to rejoin us and for final comments.
Well, I am here. Thanks, Wes. Our entire industry has really had a tremendous effort for many years now in trying to address some of the environmental impacts and making the net zero carbon emission goal a reality. And I think this panel is just great in terms of the role of data link technology and how it can actually lead to improved flight efficiency and safety. And I was especially struck, of course, from Kieran and the role of improved spectrum use and how it's going to really do a lot, not only today, but certainly in the future, to provide some efficiencies in air traffic control, and how we can be looking what we need to be doing as an industry to work with other industries to develop some of these standards collectively and cooperatively. I'll just give a quick shout out. We have a special committee 242 on the RTCA side, and the EuroK Working Group 124 that are working exactly on this, on spectrum compatibilities, and working with some of the folks in the telecom industry on some of these future things. So we're trying to do what we can do early on here to make some of those relationships working together a reality. I want to thank our panelists, Wes Googe from American Airlines. Thank you for moderating. Anna Broyce from Eurocontrol, Kieran O'Carroll from IATA, Rocky Stone, formerly with United, and Kathy Torrance from the FAA. Thank you all. Great panel. Yeah, I want to thank our sponsors for today's event, the Airline Pilots Association and L3 Harris. Again, the recording of all of these sessions are going to be available in the events lobby through November 24th, and presentation slides will also be posted in the events lobby later today. Again, we have some pre-recorded sessions that we did before today that you can access through the RTCA website under rtca.org/events, and those being from SC 206, Working Group 76 on aeronautical information and meteorological data link services, SC 214, Working Group 78, and Working Group 92 on standards for air traffic data communication services, SC 216, Working Group 72 on aeronautical information system security, and Special Committee 223 and Working Group 108 on Internet Protocol Suite and AeroMax. So be be sure to check out some of those pre-recorded sessions. There's some great information in those recordings. So Anna, great event. Congratulations. We did it. We got through everything. Certainly want to, again, thank all of our speakers and our sponsors, and especially for our teams here at RTCA and EuroK who put a lot of hours into making today's events happen. Anna and I are really lucky. We've got a great staff. Andrea Berry, Kendall Gabor from RTCA, Yago Grilla from EuroK, Mark Blay, who served as our technical director, all did a fantastic job in getting us ready for today. And again, thanks to all of you who joined us, all the attendees. Appreciate you taking time out of your busy schedules to be with us today. Anna?
Yes, I couldn't agree more with you, Terry. A big shout out to the teams, to all the speakers, all the moderators for all the work that you've done preparing this event and bringing this live today. So big round of applause to all of you, even though we're virtual here. I think I really couldn't agree more also with Wes's closing remarks. I think this event has been very informative. I've learned a lot, and I think we will all together continue learning a lot as we move forward. I think the event showed that there's tremendous potential for future connectivity on many different levels with potentially huge effects. The white paper is really a great starting point, but much more has to be done. Lots of work's ongoing in CESAR, we've seen in NextGen and other modernization programs all around the world, and clearly we also see that this is really just a starting point, as the panelists in the opening session really pointed out also, and that there is lots of discussion and communication still ahead of us.
Yeah, we kind of look at things from the standards development perspective, and certainly those are going to be very, very important going forward, but they are just an enabler, and but they're an essential one that's going to help us move from that role of innovation and into implementation. And certainly I know RTCA and EuroK stand ready to support any of those future standardization activities that are going to be required when the time comes. But again, we'll be working with both the regulator and industry to initiate those when they're ready. And I'll give you the last word.
Oh, what an honor. No, but I think you said it. This innovation to deployment, this innovation pipeline is becoming increasingly important as we move forward. And I think also what we've seen is today that the coordinated effort from all the involved stakeholders will be required to get it right. And really, we don't have much time to lose. We need to get on with it. So again, thanks to all of you. Thanks to the speakers, the teams, to all of you for attending. Feel free to review the session recordings and the on-demand sessions. I found it to be a very interesting event. I hope you found it useful and enjoyed it too. And see you soon.
Bye, everyone.